In this video we're going to talk about balancing equations, and I'm going to break this down into three simple steps that I'd like you to follow. Now the first step is going to be to count the number of atoms on the reactant side and on the product side of the equation. If you want, and we're not going to do this in this example, but you may count polyatomic ions. For example, if I have carbonate, CO3 2 minus on each side, then I can go ahead and I can count that as just one thing, as long as it's on both sides. But we don't have to worry about that right now. Let's just do a simpler problem here. So the first example that I'm going to give you here is H2 plus O2 yields H2O. Now on the reactant side we have oxygen and hydrogen, diatomic molecules, and on the product side we have water, H2O. The first thing I'd like you to do is I'd like you to go ahead and I'd like you to check to see if this is balanced by counting the number of hydrogens and of oxygens on each side. Let's take a look first at oxygen. Since it's O2, there are 2 oxygen atoms on the reactant side. And we have H2, and since it's H2, there are also 2 hydrogens on the reactant side. On the product side, we have H2O. Meaning we only have one oxygen. If you see right here there's no subscript, we can assume that means a little 1. And for hydrogen it's H2, so we have 2 hydrogens. Now we need to double check if the number of each atom is going to be the same on the product and the reactant side, and in this case it's not. So is this a balanced equation? The answer is no. This is not a balanced equation. So now what we have to do is we should set up a table with the number of products on one side and reactants on the other side. And just for the sake of simplicity, let's go ahead and let's just put the reactants on the reactant side and the products on the product side. Makes sense, right? Now let's go ahead and let's count this, and we had said before that in this case there are 2 hydrogens and there are 2 oxygens, and there's, in this case, there are 2 hydrogens, and there's only 1 oxygen on the product side. So how do we fix this? Well, the next thing we can do, and the final step here, is to change the number of atoms on each side of the equation by, and this is very, very important, by adjusting the coefficients in whole number increments. It has to be, and a circle is like 5 times, it has to be in whole number increments, okay? So you need to make sure that you're following that rule. You can't have half an oxygen atom. It wouldn't be an oxygen atom, right? So let's go ahead and let's do that. Let's take a look, and let's do this and simply just take a look at the number of hydrogens and oxygens. And since we have only 1 oxygen on the product side, it's natural to assume that we need to have 2. So let's go ahead and put a 2 in front of H2O. Now that changes oxygen, so that instead of having 1 oxygen, we have 2. That matches, and that's good. But now, since it's a coefficient, we've also changed the number of hydrogens. In this case, since we have 2 H2Os, that it's going to change the number of hydrogen to 4. And we're not balanced with hydrogen now. So what we have to do is we have to find a way to balance hydrogen. And this is pretty simple. Since we have H2 on this side, we have to basically just double that. Since we have 4 on the product side and we only have 2 on the reactant side, let's just double H2. So we have 2 H2 now, and that will give us a total of 4 hydrogens, which will give us a final equation, I'll write this in blue, of 2 H2 plus O2, we don't have to write that 1, it's invisible there, yields 2 H2O, which is our final balanced equation. We followed the law of conservation of mass, and we're all set with this.